All right, so we're going to talk about my homework 2. And essentially what I did is I used the Detectron2 model, and I wanted to train this model to be able to detect plates, mugs, and bowls. So I went with the application side of the homework assignment. So the first thing I did was downloaded the images that are required. So I used OIDV4 and got mug, plate, and bowl. And I had 300 of those images in my training data set and 100 images in my validation data set. And there's a lot of prep work that I had to do to get the labels. So a lot of these classes or definitions and functions are for those labels. Um, and creating image dictionaries for those. So here I've created image dictionaries. Um, And some of this code I actually took from a Medium article, so I've referenced that in my documentation. Okay, and then after that, I also have to register the two data sets, the train and validation sets. And I also check the image dictionary to make sure that it's appropriately loading. And then we train. So I used faster RCNN as the backbone, and I trained the model. And then from there, I tested this new model on my validation set just to see randomly, if it was working. And I got COCO evaluation metrics. So here you can see for bowl, mug, and plate. I then tested on a random image from the internet. So using our custom model, it predicts that this is a mug at a 95%. However, if I use a generic model, I use the Retina net, which comes with COCO detection. It marks it as a clock. So it shows that my trained model is definitely better than the generic model in this case. And then part 3, because in Colab it gets rid of all the files or all the variables, I wanted to make it easy to run without having to train the model all over again. So here you would have to install a few things. You'd have to install Detectron2, but I do have the config file as well as the output path saved so that my trained model, using those two files, you can customize Detectron2. So what I mean by that is here. So I saved my config.yaml and model underscore final path for my trained model. So I found another image online, which is a bowl. And using my trained model configuration, I'm able to detect that it's a bowl. I also wanted to do this using video, and I downloaded or had to install GStreamer with OpenCV, and this actually took quite a bit of effort, especially on Colab. So a lot of this is that installation process. I then had a file called mugs.movie, and I'll actually just show you the file really quick. Okay, so it's just a file movie that shows various plates and mugs. And what I did was I used CV2 and the label draw instance predictions method to be able to draw labels on each frame. So I'm going to go ahead and run this to just show you in real time. And it should save this video output to something called outgstream.mp4. So it takes a while to run. And I've already run it before and I have the file. So while this runs, I'm just going to show you what that looks like. I'm just going to pause on one of the last images. I only did 4 seconds from a training perspective because of the time it took to do all of these labels. But you can see that it detected bowl, plate, and bowl. And in different screenshots, it seems to detect the various things that are on this All right, so let's take a look at how far this has gone. All right, it still needs about 20%. And I just want to show you that this also works in real time. And that's the purpose of doing this. Okay, I'm going to refresh just to make sure it's, and there it is. All right, so I'm going to download this. This takes a little bit of time as well. All right, let's take a look and make sure that it matches what our other demo looks like. Yeah, it does. So I've shown you how my trained model can detect bowls, plates, and mugs better than generic models can. And I also have the saved config file so that if you want to use that model, you can. You just need this information. Okay, thank you for watching.